Hello, my name is Satya Devdas. Today we're going to make a water flow controller. Here's what we need to make the project. We need one long stretchy pipe, we need one motor, two L pipes, a screwdriver and a nose plier, jumper wires, and an Arduino, and we are going to take our ESP8266 and our Arduino. We're also going to take male to female jumper wires. We're also going to take a connector pin and 3 jumper wires connected to it. Put the blue jumper wire to the ground pin. Put the yellow jumper pin to the TX pin. Put the orange jumper cable to the RX pin. Put the gray jumper wire into the 3v3 pin. Put the brown jumper wire to the EN pin. Put the ocean blue jumper wire into the 3.3 volts pin. Put the blue jumper wire into the 5 volt pin. Put the yellow jumper wire into the A3 pin. Put the orange jumper wire to the A2 pin. Now we're going to get our water flow sensor and 6 male to female jumper wires. Now connect the male to female jumper wires to the water flow sensor motor. Now we're going to grab one of the jumper wires from the water flow sensor and connect it to the ground. Now we're going to grab another jumper wire and connect it to the 5 volts pin. Now we're going to use the last jumper wire and connect it to the A2 pin. Now we're going to take one of the pipes and twist it onto the water flow sensor. Now we're going to add another pipe and twist it to tighten it. Now we're going to twist one of the pipes facing upwards and one facing downwards, like this. The water pipe should look like this. Now we're going to grab our battery connected to a plug and plug it into our Arduino. The goal of this code is to collect the information of how much water is being used, and then calculating it into how much water is getting used per minute, and then per hour, and then maybe per day. And then it is transferring it onto the big wide web. First, we define all the variables we need, like flow rate, sensor pin, and etc. We also define SSID and power for the ESP module to connect to the internet. Here, give your house internet name, SSID, and password. If you click on the wireless icon, you will see all your wireless names. In setup method, we attach a method pulse counter to the interrupt pin for falling mode pulse mode. So whenever the sensor senses a water flow, it senses an interrupt signal, which we count. In above, we are attaching sensor interrupt pin to call pulse counter method for every falling point of the PMW pulse. In setup method, we also initialize all the variables and set up ESP module by calling it send AT and connect Wi-Fi methods. In loop method, all we have to do is calculate the water flow by checking our pulse count, which is incremented whether we got interrupted. We also do the calculations for every minute, so we have to wait for B4 before doing our calculations. We also do one thing, as we disable the sensor interrupt while we are calculating so that we don't mess our calculations. Detach interrupt, sensor interrupt. After calculations we attach back, the code also uploads the data to the internet using our ESP8266 chip. Please check below the URL for module AT commands.
Just go quickly.
As you can see, it is working really well. It is controlling the flow of water from the tap. If you want all this code for this machine, go down to the description and go tap on the GitHub link for all the code.